Okay, so thanks. Right now, so I'm not here as the governing board member opening something or whatnot. I'm actually here as the representative for Kokkos. That's been a project I've been involved with for a while, basically my whole life in the US, and we're very proud of it. So one question: who here actually has used Kokkos? Can you raise your hand? Yeah. Okay. Great. Can we do that again? Very good. I'm going to send that to my program manager. They always ask us, for evidence that we are important and that we deserve, to get the money we get, and this is, good. So, in that case, actually, the slides are probably going to be a bit boring, right? Because most of you know that, but they are updated. So this is, this is what Kokkos really is about, right? So Kokkos has always been, the philosophy was here that we're gonna isolate you from all the, different things happening in the hardware world and make your life easier, right? You decide to write your code in Kokkos and target, the Kokkos libraries and the Kokkos interfaces, and we will map that to the underlying architectures. And that is true for a very large number of different types of applications, right? So this is not just for one specific area, this is for general kind of computing, right? Mostly, obviously, we started in HPC, and everything you do in HPC, there is probably somebody doing that with Kokkos, right? We have computational fluid dynamics, molecular dynamics, electromagnetics, climate simulations, you name it, and you'll probably have a code which does that with Kokkos. And when you target, underlying architectures, and who can spot the most recent update on the platforms down there? Yeah. Yeah, exactly. Alps. That was the most recent update I made to that slide. I mean, one of our premium members might be very happy to see that thing, right? Because we are probably responsible for 4 of them. But we're basically targeting everything, right? AMD GPUs, NVIDIA GPUs, Intel GPUs, CPUs, right? CPUs are still very, very much important for us, right? We have, particularly as somebody at Sandia, right? One of the primary machines our users are supposed to use is Crossroads, which only has Intel CPUs, right? So what is Kokkos? It's a C++, programming model for performance portability. That is really what it's at its core. It's implemented as a template library on top of other things, things like CUDA and SYCL and OpenMP and HIP and whatnot. Actually also HPX. One of the real goals was here to have something which is easier to use than, say, CUDA or HIP or OpenCL or whatnot, which existed back then. We wanted something which the typical kind of HPC application developer can use without becoming an expert in the vendor-specific models. So we are aiming to be descriptive, not prescriptive, which means, you tell us really what you want to do, and we decide how to do it, right? You don't get control, kind of fine-grained control over what's going on underneath. A lot of us in the Kokkos team have been very, very active in the C++ standard. That is, part of our mandate, our funding mandate. We're trying to achieve, part of our sustainability through aligning with the C++ standard and even like shaping the C++ standard. At some point, the Kokkos team was sending roughly the same amount of people as like NVIDIA or Bloomberg. We were actually basically the third largest, as an institution, we were the third largest contributor to the committee. And one really important thing is for Kokkos, you use the vendor tool chain. Right? That's a difference to things like, for example, SYCL, right? You actually use the preferred vendor tool chain. When you compile for NVIDIA, you use NVCC as your primary choice. When you compile for Intel, you use Intel One API, DPC++. When you compile for AMD, you use AMD Clang++, right? We also support all the other the open ones, right? You can compile with, upstream Clang. You can compile with the Cray compilers. You can compile, with whatever you want, GCC. But beyond the programming model, when you start writing applications, you notice, oh, I need something else, right? How do I now call BLAS in a portable way, right? And that's where other things in the Kokkos ecosystem come in. The important thing here, something I want to emphasize is that it's not just for GPUs, right? These codes are supposed to then also run at least reasonably well, right, on CPU systems. So this is the current Kokkos ecosystem. Up top are the things, which are, the more stable, mature things, people use a lot, where we have a lot of confidence in. Kokkos core, obviously at the core of a programming model, parallel execution, parallel data structures. Kokkos kernels, then linear algebra, sparse linear algebra, dense linear algebra, graph kernels, and so on. Kokkos tools for interfacing with profiling, debugging, tuning, and so on. And the support effort, doing things like tutorials, doing things like hackathons, actually making sure that we have decent documentation, etc. Now that we've started growing a bit, and part of that is actually, as part of this kind of HPSF development in some ways, right? We've started expanding the team a bit, and some of these newer contributors brought in other ideas, things which were missing in our ecosystem. Things like, we didn't have a good FFT solution, right? And so people had started working on an FFT interface, right? Which calls other libraries underneath, but at least you have a native kind of Kokkos interface for it. Kokkos.com, for example, the MPI interoperability is something which recently was added. Some of these other efforts, which things like interoperability with Fortran is still a big story, right? It's something where within the Department of Energy, in particular Los Alamos, has still a lot of Fortran codes, and they start using Kokkos, right, for getting onto GPUs. But the same thing we see, over in Europe, right, where the total fraction of Fortran was actually still quite a bit higher than in the US, right? Here in the US, in particular, a lot of the larger organizations had already, started to move away from Fortran. But so that's a big story, right? Interoperability with Python is a big story. We maintain some of these things, with C++ libraries, things like, features for future standards like MD-span, which technically is part of C++ 23, right? We maintain an implementation which works all the way back to C++ 17 because, people need to use it with compilers we have right now instead of the compilers we are waiting for. What does that all buy you? This is an example we are particularly proud of. In 2023 at Supercomputing, one of the Gordon Bell finalists and actually won the Gordon Bell Prize for climate modeling. That was a Kokkos-based code. And what I like about this plot is, right, so they did this plot where they ran on all these different machines, right? So you see there's one with an MI250, so that's an AMD GPU in there, essentially Frontier, right? There's also, I think the A100 was probably Perlmutter. The V100 was, the kind of Summit Sierra style machines. But we also have the CPUs, the pure CPUs in there, right? And one thing you see here is they compared that to their previous Fortran code. And the CPU performance was also good, right? This is something we've seen in a lot of the more mature codes. We saw stuff like the curve here, what is that? That's the epic curve, right? Where even on pure CPUs, their code got better after rewriting to Kokkos. Not because Kokkos intrinsically can give you better CPU code, right? But, I said we have this descriptive model, right? You tell us what to do and we decide how to do it, right? What that does is it actually puts a lot of restraints, guardrails on the user. They can't just do anything they want. Like one of the things they're not allowed to do is they're not allowed to willy-nilly allocate new memory inside of loops, right? And it turns out if you prevent the users from doing that, their codes go faster because it's a really, really bad idea to do that. And that's something we've seen with a lot of mature codes, right? Almost all the really big codes we had got faster across the board, also on CPUs. And obviously, maybe in this crowd as well, there are some exemptions to that, where if you really, really well optimized your code, right, then sometimes these abstractions can make you a bit slower, right? But that's the kind of more general picture. So our Kokkos community, right, and why HPSF matters. I said our development team has been grown quite a bit, right? We started out way, way back, what is it now? 13 years ago or so in Sandia only. And ECP helped us grow a bit, right? In particular within the DOE community. So we got a really strong team in Oak Ridge. And now recently CEA joined with their own effort, with their own funded effort. And that's really the main of the development team, right? These three organizations are really carrying the project right now. And then there are a bunch of other organizations doing some support efforts. What HBSF gives us, right, is the neutral governance, right? We can really do a true partnership, right? It's much easier for our European partners to explain to their funding sources they contribute to a Linux Foundation project than, saying, oh, we are contributors to this DOE thing or even the Sandia thing, right? Along with that goes, that our assets are held in trust by the Linux Foundation, right? Like our website and whatnot. We get project support for infrastructure and outreach, etc. Our community has been diversifying as well quite a bit. At this point, when we go just, looking at our Slack users, right? We have about 2,200 or so in there. And, the DOE fraction of that has shrunk all the way to, almost just a quarter, right? It's like 26% or so right now. And that is very different from where it was like 4 years ago or even 2 years ago, right? And we are really, really happy about that. I personally really like that we have a trademark now, which gets enforced, and not random people, or other people can just call their things Kokkos something. It really helps us with bringing the message down, this is what is the real project, right? And what is really funded. What do we want? The same things as other people, right? We want our community growth. We want to grow geographically. We want to find new leaders, who can be part of this. We want to strengthen our collaboration with industry. I think we have a lot to offer for, people outside of the academic and labs sphere. We want to reach these new areas in potentially in terms of where Kokkos is used. We definitely have been working really hard and want to work still hard on robustness, right? We've been doing the things like the OpenSSF best practices batch, etc., right? Performance testing and so on. And if you want to learn more, right, you can come to our Kokkos user group meeting, right? That is, we will have 2 days. We'll get some updates from the Kokkos team. And you get a lot of presentations by users, right? And we'll have some, people who've been here before at our user group meeting, which was way, way scrappier than what we're doing right now. I don't know, the people who came can tell you about that, when we had to go on our own to get the coffee from the coffee shop and distribute it, etc. So I'm really happy that we have now this all sorted out. And there's a lot of new people as well. Right, we really see that the community is growing, and we're really happy about that. And so, if you want to check that out, Wednesday and Thursday, that's when you can come and learn more about Kokkos. Thank you.
Thank you. We have time for one quick question. Anyone? Yeah.
Hi, so I was kind of curious with being under the Linux Foundation, if someone wanted to contract, supporting a particular hardware or set of kernels, is that possible? Do you have signatory authority? Do they have to go through the Linux Foundation to set a contract up, between another institution and yours?
No, right? So the way this would work is you would find somebody who would be willing to do the work, right? And they need to essentially talk to the Linux Foundation project, right? Also to us, right? That this is in agreeable state, right? It's the same as an LLVM, right? You can pay random people to, or random companies to implement something in LLVM. Whether or not it's accepted upstream is a different question, right?
Yeah, so as part of a grant, you could, say that, I want to, we will have this piece necessary for us to do this scientific work, and we're sort of, reducing the risk by saying that it'll be directly done with someone with, well involved with the project, so that type of thing.
Yeah, I mean, what they should do is they should come to us and have somebody potentially involved from the core team, right, to make sure that it's very likely that it gets accepted, right? Okay. I mean, you can never promise it, right, and from a pure kind of legal perspective, right?
Okay.
But I mean, be very unlikely and very much not in our interest to reject these kind of efforts, right, if they come to pass.
Thank you, Christian. Thanks again.